Hi everyone, I'm Anthony with Open Mind Garden, and I've had the privilege and pleasure of meeting Yannick Van Doorne in person. So it's been a pleasure. Yannick has been showing me around his garden, some of the experiments that he's been doing, and it's really cool for me because I found out about Yannick's work last year and I saw many of his videos. That it's one thing when you see videos online, but it's another thing when you get a chance to actually witness in person. So it's been a very interesting and amazing experience for me, and I'm very grateful to Yannick that he showed me around. And so now we were just gonna have a little conversation about electroculture, about the past, the present, what we see, what we foresee as the future of electroculture. So to start off, I'd ask you, Yannick, in the past we've noticed that electroculture has been around for maybe like the past 3 centuries or so. It started like in the 1700s, and now it's like having a resurgence, and in large part too because of the work you've done the past 2 decades. It's been seeing a resurgence. What do you see as the reason why in previous centuries many of the researchers were unable to get consistent results? Like they were getting mixed results, where some of them were getting positive, they were getting good growth, and other researchers they were just not getting good growth, and they were even the same experiments. Why do you think that is?
Ah, um, First, I welcome you. I'm very happy to show the garden to guests from all over the world, and Anthony is coming specially from Minnesota to visit my place. So I take extra time for him for showing and what I'm doing and we exchanged a lot today. It was really very nice between passionate about electroculture. We have a lot of things to share and ideas to share. So, to answer to your question, well, today we have a lot more technical measurement possibilities of electricity as 300 years ago. Today we can measure voltage, amperage, frequencies. We understand a lot better how electricity can influence plant growth and how it can influence soil electricity. So it makes it possible to improve the systems that they didn't necessarily had all that knowledge 200 300 years ago. Two, 2 or 300 years ago, electricity was just it is present or it is not there. So they were like looking after it and looking how they could harness, receive, transmit, transform. And so in some setups they had huge results, and so this gives a lot of motivation to go further and to do more experiments. And in some other setups they had no results, and sometimes it's little details that makes that you get those results. And now with our viewpoints of today, with our knowledge of today, it's maybe sometimes more easy to understand why some had really good results and some others not. But we are still in the beginning, really, the awakening of electroculture. I think we are really the pioneers, and in later time it will really explode of new technologies and new techniques. I think we are. That's also why I like it, because it's so. Yes, you feel you are like discovering a new continent.
So
Yeah.
it'd be safe to say like we're really just scratching the tip of the iceberg with electroculture. Even though it's been studied for like the past 300 years, it's really now that we have many more advanced tools, we have technologies that we can actually take more precise measurements, and it's worthwhile to take these measurements because then we can actually see, are the results that we're getting because of electroculture, or it could be, other like confounding factors or other variables at play, right?
Yes, yes, there are a lot of variables that can play, yeah? And that's we are like touching the invisible spectrum. Magnetism, electricity is something invisible. You need measurement devices, and we are refining all those tools, and our scientific knowledge is still growing about how today in physics, it's about quantum physics, fields, quantum fields, and all those kind of things. So it's simple and very complicated at the same time. And with electroculture, we discover that we have influence of sunspot activity, for example, that influence the electricity and the magnetism on Earth. But we have also the influence of natural cycles of electricity in the soil, like you have a soil current, a natural current going through the soil from that is at minimum around December and maximum in June. So all those things 200 or 300 years ago we don't know. So, but all those things have huge effects also on some kind of antennas too, an effect. So I think an electroculture doesn't put away all the classic practical all the classic knowledge of agriculture. We need also to be careful about having a good soil and temperature, light, all those basic influences on plants need also to be optimized to get the best results. It's not only about electroculture. The electroculture aspect is just that we will look at the whole field of electricity, magnetism, energetics around the plant in the environment, and until now we didn't did much research about those influences, but we see that there are huge influences, and when we optimize the magnetism of the earth, for example, we see that the plants grow a lot better. So it's a parameter, or it's a factor above complementary to all other factors that influence plant growth that we discover. So, sometimes scientists think, now we know it all. Now we understand light. We understand the influence of temperature of plants. We understand the physics of the chemicals in the soil. But with electroculture, it's just a whole new continent that opens of discoveries and new influences that we need to now to study and to understand how it influences plant growth.
I'd say one of the things too, at least from my perspective, because I stumbled across electroculture last year when I was watching Yannick's videos and I was seeing other content online about electroculture, and my perspective has been that many people have gotten interested to test in their own gardens on their farms, and I think one thing that we all, even as researchers and non-researchers, we have to be careful about like confirmation bias too, where it's like we're expecting a result and like sometimes the result happens, but it could also be because we like might not necessarily even be electroculture. It could just be that we wanted to take care of the plants more, right? So it's like, okay, we introduce an electroculture technique in the garden, and then it's like, okay, I'm gonna put more compost, like more of those materials. So is that something that you also keep in mind, like when you're doing your experiments and stuff, like you keep in mind, like, okay, I have my bias, I need to be careful too, because like I love electroculture, I know it's gonna work, but then I also have to be careful, like when I do these tests, like to fight with my own bias, right?
Yes.
It's a valid point.
Um, um, I'm completely convinced that our emotions, our um, um, our positive thinking, or prayers or intentions have also huge influence on life and on plant growth. So, if we put an electroculture antenna with a positive intention, uh, we will have part the effect of the antenna itself and part of the effect of our relation to it, like you tell, and so it would be good. That's why science is very important too. It's to distinguish from where comes the effect, from where and do repeatable results, repeatable experiments that works everywhere, and not only this gardener or this farmer, because when we put extra care, it necessarily will help the plants growing better, and it's good to make experiments where we are really very objective and very neutral, and and also, like you say, it's not because we do an experiment on two plants and there's one good result or one positive observation that it's not scientific. It's just an indication.
It's a good observation.
It's a good
yeah.
observation, but then we need to do more experiments to check if it's really repeatable, if we really discovered something, or if it was just a coincidence or another accident, but a positive accident.
Yeah.
So it's important when we do experiments to check that, because today with social media, and we have a lot of observations in our garden, and we can see some trends. We can see some trends, but we have also the effect that people, when they have a good result, they share it, but when they have no
No,
result,
they don't want to share
they
it.
don't share it. So it's normal that we see only good results, but it's not a proof that it's really the effect. If we don't check it by ourselves,
Yeah.
and if we don't have a kind of scientific experiment that confirm it, it's always difficult. But that's also why I always promote the people to just try, begin, check, do experiments, but not only on one plant and another, but just a group of plants. Then you can see trends, because just one plant to another plant, it's really not enough. Yeah.
Yeah. So going off of what you just said, like I remember in one of your videos last year that I was watching, you had kind of given out that challenge, like see for yourself. Like if you don't believe the results, like you were giving a challenge, like test it out for yourself. So when I saw that video, I was interested to test it out for myself. So what I did was I saw your videos and I planned last year to test your antennas in an outdoor field plot. So what I did was I got 12 of Yannick's those atmospheric antennas with the 3 spirals, and I tested those outside in Minnesota on a farm plot where I connected them to like 10-foot rebar poles, and and I know my experiment wasn't perfect. Like it's almost impossible to have like a perfect experiment, especially when you do outdoor tests. Like there's so many variables you have to try to control, but that's the goal where it's like you want to have a big enough sample size to try to control some of the variation. So I chose the number 12 because I saw in other literature, in peer-reviewed publications, that if you're doing like an outdoor test, it's good to aim for at least like 12 to 15 replicates. So that's where the reason why I decided on 12. So what I did was I had 12 rows of treatment. So the 12 rows had the atmospheric antenna connected to the magnetic antenna underground, and then 12 rows control. So they were just plants that I planted directly into the ground, no changes at all. So what I did was I focused just on a plant that's called Japanese mustard green. It's a leafy green. It's in the Brassica family, and so I direct sowed this mustard leaf last year in the middle of summer, like in the peak summer heat in July. I sowed 12 rows of control with this seed, and then 12 in the treatment. And over the course of from July to about September, October, I was trying to take measurements like once a month. So I was sampling the leaves and just observing. Like each week I would go out to see, because I was very inspired when I saw Yannick's videos. Like I believed what he was sharing, but in a sense, like I needed that final confirmation. Like I needed to test it for myself. I needed to see, okay, does this really work? So I was there checking, and also with my entomology background, I was curious to see if there was an effect of the antennas on like the local insect population. So every time I would go out there to see, I would notice, and this is kind of my anecdote, that anecdotally, I noticed that as the weeks went by, I noticed that in the treatment rows, there seemed to be less pest pressure. Like, this was my anecdotal observation. I wasn't able to really quantify it. The way that I did try to quantify it, though, is that I used a smartphone application. It's called Leaf Bite. You can take a picture of the leaf, and it actually gives you an estimate of percentage herbivory, so percentage pest damage. So I did take those measurements like after a little over a month, and I noticed there was a slight difference, but not like significant difference. But as the weeks went on, I did notice though like less pests in the area of the treatment row. So that seemed interesting to me. And then as far as like comparing between the two groups, I noticed that after about 2 months is when I noticed my first like significant result. I had randomly sampled across each of the 12 control and 12 treatment rows, and I noticed that while I didn't get a significant result overall, I did see that the largest leaf from the treatment groups, it was about anywhere from 15 to 20% larger than the largest leaf of the control. So I noticed that, and like when I visually saw the difference, like I was amazed, like I didn't expect that. But for me, it was only one leaf. So, and I know that when I was doing this experiment, it's not easy when you do experiments and when you farm in general. It's always a team effort, because when you try to farm or do experiments by yourself, you're more prone to error. Like it's good to have assistance or people helping you out. But so I did the best I could. I did this experiment to kind of see for myself if it worked or not. And I was convinced, even though I didn't get the big result that I was hoping, for me to see that difference in the leaf size, like for me, I was convinced that something was happening. I was gonna go for results after 3 months. I was gonna take another final measurement, but unfortunately, we had like an early frost freeze in Minnesota, so it wiped out all my mustard leaves. I wasn't, and that's one of the things when you do an experiment, you can always plan ahead and you can have everything prepared, but then it's like Mother Nature comes in and like can mess things up.
Mhm.
Um,
Yes, an example like this to a farmer in Belgium. He had several hectares of wheat fields and grain, and um, he didn't saw really much difference in the quantity of the yield. But the big difference was that his wheat was like 2 to 3 weeks um, before ripe, so he could yield it 2 to 3 weeks before the others, and it was good weather at that moment. And 2 to 3 weeks after, it was always raining, and so all the other farmers around they had to wait before for yielding, and then they had mold and fungi and problems on their wheat, on their grains, and they had almost no yield. You see,
oh,
so so sometimes you think I will have a bigger yield, but that's not. But Mother Nature decided differently. It's there it was that your yield was ready sooner.
yeah. Well,
That the plants were growing faster, but it was not so bigger. So it was every time it's something different, and like you say, we need to take into account Mother Nature. And every year I see in the garden, the results are quite different. There are years where you have huge results on raspberries or rhubarb or lettuce, and other years is on the tomatoes, and so it's every year it's different. But overall, we see really the difference between with electroculture techniques. There are many techniques too, and without, if you begin to test, you begin to see things for sure.
yeah. And going off of what you were saying, the experiment that I did notice though visually when I was comparing the treatment and the control mustard leaves. Usually, this Japanese giant red, it's supposed to turn like a violet reddish color. And I personally observed that in my treatment rows that were treated with the magnetic antenna connected to the atmospheric antenna, I did notice that most of those treatment rows, there were more leaves that were more like a vibrant, healthier purple color. Like I noticed that compared to control, like there was less of that. Like I know that my eyes weren't deceiving me. I did see that, and I also had the other farmer that I was working with last year. I had him come out to the field with me, and I told him like, "Do you see what I'm seeing? Like, do you notice a difference?" And he agreed with me. He said that yeah, it looks like there is a difference. So I maybe like you were saying, I didn't get like an increase in yield necessarily, but I did notice that like they just look healthier. Like there was slightly less pest damage,
Mm.
and the leaves look more vibrant purple.
Yeah. Well, mostly when they did when they did testing of the nutrient analysis, there was almost always 20-30% more essential oils or concentration of nutrients, and so it's normal that the plant looks more vibrant and more colorful. But that's something very interesting to do in scientific experiments. It's really now we have applications where you can do like a spectroscopy, where you can measure the light and the colors and compare, and this can give an idea of the health of the crop also, and that's instantaneous. An instantaneous experiment and quite easy to do. Yeah.
Why do you think then like it's something that I've observed too in the scientific literature is that many researchers have been getting this seems like a magical number. It's like a 20%, 15, 20, 30% like increase either in nutrients or yield. What are we just stuck at that range, like 15 to 30%? Or do you think it's possible with like improvements or changes in electroculture techniques we could push the barrier and maybe get up to like 50%, 100%, like consistently, like season after season? Is that possible?
Yes, yes. I give just an overall picture, but on some techniques and some plants, it can be a lot bigger the effect. Um, I saw already I saw already double and sometimes a lot more growth with and without electroculture. But it depends on a lot of variables. An example, if you don't give any fertilizer, not any, even not organic one, and you put electroculture, you see a lot bigger difference than if you already optimize the fertilization and things like that. Depending on the situation, you will have a lot bigger difference. Um, but I just shared some numbers from scientific studies and that are known. But otherwise, sometimes in gardens we see a lot bigger effects.
Sometimes there's cars that are coming by, so that's very. It just seems strange to me because it's like I noticed this across many papers where they were showing like 20, 30%. And I just ponder like why were they getting those numbers?
Yeah, there's also something in science, I think, and in the psychology of human. If you do an experiment and you say I will increase by 150% the yield or something, nobody believes you.
Yeah, it's almost unbelievable. Yeah,
It's almost unbelievable, and then they like to have a little increase, you see, and then the paper
it seems more realistic, right?
seems more realistic and is more accepted by other researchers, and then the paper goes through all the barriers to be published, you see. I think there is something because but I saw already in gardens really a lot bigger results. It's possible, but um, uh, yes, it's
Well, so actually, you reminded me. There was one interesting paper that I had read recently where I think it was out of Korea or Japan where they tested like air ions or anions, and these like negatively charged ions, and they did it like in a greenhouse environment on like spinach, and they did find like an increase or an improvement in the nutrients, like 50 to 70%, so
Ah,
much higher percentage.
ah, yes, that's a lot, a big increase. Yeah, yeah. What we also have to be conscious of is that you have plants, you have some plants that will react a lot to magnetism, for example, to influences of variations in magnetism. Other plants will react a lot more on electrolysis or electricity in the soil. Other plants, it's like you have plants that are very influenced by the light or the daylight hours, the length of the day, and other plants is the temperature. Other plant. So for each plant, you will have other results. So with the same antenna or with the same electroculture technique, you will have plants that will react a lot more than others. Uh, because in nature too, you have plants adapted to all situations. A plant from a desert is not the same as from a rainforest, or one likes water, the other doesn't like too much water. So
Yeah.
it's well, with electroculture we have also that aspect. There are plants that like very poor soils, and other plants like very rich soils. And I think we will discover that plants like very high magnetism, and other plants like low magnetism, maybe. It would not be. I would not be surprised that it is like this.
So then you think it's fair to say that we could find, like, maybe in the northern hemisphere, the atmospheric antennas might work more effectively just because there's like more, either thunderstorms or whatever. The climatic conditions are more favorable to the antennas,
Other.
whereas
uh,
maybe the other way around, where it's like in the equator, near the center of the earth, where there's a lot more thunderstorms. So maybe the
mm,
antennas could work more effectively there. Whereas if there's like less thunderstorms, maybe in a desert environment, then maybe using a solar panel and just making like an electrochemical cell, that might be more effective. Like trying out those different
yes,
techniques.
that's. Um, I think we will discover in future more effective techniques for every situation. But now the example of the atmospheric antenna, uh, we can think of that logic like you explained, but in the reality, I received testimonials of very good results at the equator and also in Europe. So I don't see really different results for that technique, but probably we will have different results with certain techniques. An example, to put a basalt, paramagnetic basalt in the soil, that increases the magnetic intensity of the soil. So we could say, well, if we put in the soil that is already paramagnetic on a volcano, we will not see much difference, much results. But if we put it in a soil that is very poor in magnetic energy, we will see we, we could get a potential increase of fertility that is a lot bigger. So because we know that and we can measure that. Now, it's true that the electrical activity is different in the mountain than in the plain, than in close to the poles, or than on the equator. So probably there will be techniques that have will have more effect or less effect at certain places.
Yeah.
That seems quite logic, but we need to find out. We need to test and to cross all the testing from the whole world to know that, and that's what we need to do. The more we do experiments and the same experiment all over the world, then we can learn a lot of new things too.
And right, and in a way too, like it's important that, like, people don't even necessarily, they don't need to have like a PhD background or a research background to do a good experiment. Like people around the world, they can set up an experiment, even simple ones, and like that will be very valuable knowledge and information
Mm.
that it can help inform us around the world, like what works, what doesn't work.
Yeah.
Because I think my impression is that from seeing in social media and reading comments from people, that maybe some people are hesitant to do bigger tests, or they might not want to try testing new things because maybe they feel like the topic is too complicated. But I think electroculture can be within reach of everybody. It's obviously a very complex science. It takes time to understand. Like you were telling me, Yannick was explaining to me earlier that he didn't understand electroculture initially. Like it took you time to trial and error to really understand how the systems work. But then it's like once you really you kind of learn from the trial and error, right? So it's like people shouldn't feel afraid or they shouldn't hesitate that if you want to test electroculture in your garden or farm, then it's like, go for it. Like, take on the challenge and try it out and see. Like, just like when I was a skeptical initially. Like it was hard for me to believe when I saw videos online, and even when I saw Yannick's videos at first, I was skeptical. I didn't believe that it could work. And then when I tried it out in my own garden in my farm in the farm plot, and even though the result that I had wasn't very huge, what I did see convinced me enough to do more, to try more, because I do believe that there is something there. And more so now, after Yannick gave me a tour around his gardens here, and he showed me some of the experiments that he's been doing. It was really cool to see up close, some of the videos that he was sharing before. So, and I saw it with my own eyes, like, yeah, there is a difference. Like, I did see that, so it's very, very interesting.
But
Uh,
I'm like you too. I began also like this. I read the books about certain experiments and techniques with electroculture, and then I wanted to just test it to look if it's true, if it really works, and so by trial and error, I'm now today. But it's still always trial and error, and but now I have more positive positive results than in the past, where I did a lot more trial and error. Uh, uh, but it's like this that we continue, and that's why I share it also in the book, where you see a lot of practical setups and with the results I've got, or with my friends and farmers, and and this can help you already to have a basis to build upon to build and do your own trial and errors. And that's when you begin, I would always advise try directly 2 or 3 different techniques, because if you only do one and by accident you don't have results, then you are discouraged.
yeah,
But if you have some results, you begin, then it gives you hope and your more motivation, and then you want to get even more results. Then you see, yes, it's possible, and you continue.
yeah. And I would say so. I had a chance to read through Yannick's book, this electroculture guide, and I personally would endorse it. It's a very nice book. I had a chance to read through it. It's very practical, so you don't even need like a really scientific background to understand it. It has very practical information, so I really encourage, if you haven't read this book, then read it. It's a very helpful book for practical electroculture.
Yeah. Yeah, that was my goal. It's to make really a first book that is very practical, that you can directly apply in your garden or do experiments, and then later I will do more in-depth scientific, or go more through the theory and the history about it. Yeah, very so.
Where then? So where do you foresee electroculture is going to go, like in the next like 5, 10, 20 years, like in the future? Like what do you envision needs to happen?
Um, I see that since 20 years, or even little more, that I began to do electroculture, and now I see that the last year is really an explosion of interest of people. People are a lot more curious. a lot more all over the world. In the beginning, it was only in France and then some other countries, and now it's really all over the world. And I see people are really curious now. There are a lot doing a lot testing into trial and error, like in their gardens. But what I hope is that there will be more scientific people doing really experiments, serious experiments, and develop real applications for the farmers. I really improve the techniques to adapt them for big scale farming, and to because today we have all those problems of pollution, of cost of fertilizers and pesticides, and we need to find solutions. And electroculture can be one of those solutions or part of it. And I think there is really a huge demand and huge potential to develop really solutions to today problems we meet in agriculture. And yes, and we see also in the scientific domain, in the scientific societies, that there is also more and more research about really the influence on electricity on living cells and plant growth. So it's happening in reality. Yeah. So I believe we will really do a lot of discoveries in the next decades around electroculture.
It's even possible to contemplate too that as we gain more knowledge and experience with electroculture, it would be fair to say that electroculture as a movement, as an idea, even as just the potential to help bring people together, maybe even like to help bring peace to the world, right? Like it's such an interesting idea and movement that it literally has like the potential, like the electrical potential. As you know, as humans, we are electrical beings. So for me, it resonates deep down that the more we learn about electroculture, it's like the more we learn about ourselves, and it's like it helps us to connect back to the earth because like ultimately we're made of the earth, and so I feel like there's definitely some spiritual, deeper elements to electroculture, and I think the more we investigate, the more we research about this, then it has the chance to help to encourage peace and understanding, even in the midst of like differences and conflicts around the world.
Yes, 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 yes. I believe that um, in our world with all those crises, um, electroculture, gardening is 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 a subject, is a topic that brings us all together. That's where we accept the difference between each other, but where we can learn from each other all over the world. And in that perspective, it's really it brings peace, and it brings the people together, and it feeds the people, and really it feeds with real food. So it really feeds the people with only positive. Agriculture is really the basis, and if we can improve agriculture and our food supply, um, yes, it's only positive. So and 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 above politics, economics, it brings more sovereignty to the countries. Um, it makes us more free from costly practices like pesticides and fertilizers, and it improves the results, and it gives us really hope and really nice results. It's nice to have like a breakthrough like this. It's like we would discover anti-gravity, you see. But that's here. Electroculture is kind of free energy for agriculture. It's really amazing when you see the results with just a little bit of electricity. It's really amazing. There was a scientific research like this in Belgium on tomato plants. With 1 volt of electricity, they could cut 50% of the fertilizers in a whole greenhouse.
Just from 1 volt.
Yes,
Wow.
just with 1 volt, and it corresponded with around $70 of electricity a year on 2 acres and a half or 1 hectare, and it was in place of several thousands of euros of fertilizers. You see, so when you see that just with 1 volt of electricity you can have so much results, it's amazing. It's like when you have a little rain from a thunderstorm, all plants growing. It's amazing. Why don't we do more research about how nature works to make that happen? That's electroculture.
I just want to say, like, I was very inspired by Yannick when I saw his videos, and I'm grateful that I was here today to talk to Yannick. And so when I did my experiment last year, I wasn't satisfied with the results, and I knew that I could do more and better. So I decided to apply for a research grant, and I'm happy and proud to say that my research idea proposal was accepted recently, just last month. So and I want to thank Yannick for that. He's part of it. He's helping me with the research, as well as my former PhD mentor from when I was a university student. He was my entomology mentor. He's also helping out. So I'm just very thankful for you, Yannick, for this time to.
Thank you too.
It's I know that, like, we need more robust experiments and, like, more testing, as we were talking about. So that's why I'm very excited for the future of electroculture. I think that there's a lot more that can be done, and I'm just very thankful for Yannick and for everything that you've shared with us so far, for all the time and energy you've put in through your videos, to just taking your time to share all this free information. It's really special, and I'm very appreciative.
Thank you, Anthony. So I'm very happy if I can help students, researchers to do more research into electroculture. I'm there to advise you and help you with all the knowledge I built up over the years. And if it can help you to go further and discover more, I would be the most happy man on earth. Thank you very much.
Thank you guys for listening.
Thank you. So that's the book, Electroculture Growing Practical Guide. So you see many techniques and drawings that explains you how to do the round tower, the atmospheric antenna, paramagnetic basalt, with a lot of results. Really very practical.